Hey, all. So, welcome back to the AWS Machine Learning Associate tutorial series. So, today we are going to learn about Kinesis data streams. So, imagine you are running a large e-commerce platform. Thousands of users are clicking, payments are happening every second, applications are generating logs, IoT devices are sending data continuously. Now tell me, can you process all these in real time? That's exactly where Kinesis data streams comes in. In this video, we are going to understand Kinesis data streams from beginner level to advanced production architecture level, including scaling, ordering, security, monitoring, and real-world DevOps patterns. So, what is Kinesis data streams? So it is a fully managed AWS service that allows you to collect, process, streaming data in real time. Let me simplify that. It is like a continuously flowing river of data. Data never stops. Applications keep pushing. Consumers keep reading. Why do we even need this? Before services like Kinesis, we had batch processing. Logs were stored, later we processed them. But modern systems need real-time monitoring, fraud detection in milliseconds, live dashboards, instant recommendations. Batch is slow, streaming is instant. That's the shift. Let's understand some of the real-world use cases where Kinesis data streams are used. So let's take application logs. So when the application's logs are sent to Kinesis, so which can be further sent to monitoring systems, through which instant alerts can be triggered. Next thing is like let's take IoT devices. So IoT sensors continuously send data to Kinesis, which can be further sent to analytics engine for further processing. Another one use case is clickstream data. So when like e-commerce websites send their clickstream data to Kinesis data stream, and further which is sent to recommendation engines. So recommendation engines, right? Various products, according to users' preference, it is recommended to the user. So let's understand Kinesis data streams with the analogy to conveyor belt. So in factories, you see this conveyor belt. So where workers place items on the conveyor belt, and various workers do something on the items which the producers, I mean, the workers who placed it. So here each item is referred to a record, and the workers who placed are called producers, and the workers who does something on the records are called as consumers. Yeah, so let's understand the building blocks of Kinesis data streams. So a stream is a logical container for ordered data records. So when producers put data, they refer a stream on which the data records are put into. Shard is the unit of capacity in Kinesis. So each shard support 1 MB per second write, 2 MB per second read, and 1000 records per second write. So if the records fail, then we will have to increase the shards. Then a record is a individual data payload with a partition key and a sequence number. So a partition key routes records to a specific shards for ordering. So AWS internally applies a hash function on the data being received. Uh, so it with the hash function, we get the partition key, and the data is sent to the particular partition keys shard. Producer is a service or application that produces data which eventually put records into the stream for, say, an application, a microservice, an IoT device, etc. A consumer, an application or AWS service that reads and processes data records from the data stream. And producers write data into the shards on the data stream. Consumer read the data from the shards. Let's understand how to create the Kinesis data streams in AWS. So this is the Kinesis data stream console. So when it comes to Kinesis group of products in AWS, you can see Kinesis data streams, Amazon Data Firehose, which was previously Kinesis Data Firehose, and Kinesis Data Analytics. So to create Kinesis data streams, select this option and go further on, create data stream. So I am naming this as test stream. Here you can select the capacity of this data stream. There are two capacity modes. One is on demand, one is provisioned. So in on demand, like this mode can be used when the data stream's throughput requirements are unpredictable. So it adjusts to the demands of the application. So it scales automatically. When it comes to provisioned, you provision the data stream with a desired capacity um, in prior. So for now, I'm just choosing provisioned, and I'm selecting one shot for my need. Depends on your data, how much you're streaming, you can choose the shots. There is a provisioner to calculate the shot, which you can see how many records you're going to send, you're going to write per second, and the individual record size for, say, 1 MB. From 1 KB till 1 MB, a record size can be. So, and the total number of consumers. So, this will calculate the shard here, how many you want. If you go with on demand, so everything will be adjusted dynamically depending on the demand. So for now, I'm going with provisioned. I'm creating one shot for my demo. So here it is written, I can put up to 1 MB per second and 1000 records per second. And I can read maximum 2 MB per second from this data stream. And maximum record size can be 1 MB. If your record size is very minimal, then you can put the record size here. So with this, whatever we have selected in the top is accumulated here. Just click on create data stream. So here you can understand the configuration of this particular data stream, and you can see something called retention period. So Kinesis data stream. So we say this is real-time data streaming, right? So when we say real-time data streaming, a producer sends data to this data stream, and how long this data will be retained here in this Kinesis data stream is what data retention period. You can save data here in Kinesis data stream from 1 day to 365 days. It depends on your requirement and how consumers are consuming this data. So once all your consumers consume this data, you can remove, you can delete data, or the data gets expired after the retention period. So the maximum record size is 1 MB. You get a ARN. So by referring this ARN, your producers send data, streaming data onto this Kinesis data streams. So here you can see who can, like how producers send data to Kinesis data stream. So there is an agent you can get here, which you can integrate in your application. So let's say your e-commerce application wants to send data to Kinesis data stream. So you can use this Kinesis agent in your application to send data to Kinesis data stream. Or there is AWS SDK available, or there is producer library, Kinesis producer library available, which you can integrate in your application. How the consumers consume this data from Kinesis data streams. So, who are the consumers can be? So, data fire hosts can be a consumer. Kinesis client library is there to consume the data from stream. Managed Flinks, which is a analytics service, right? Which can also be a consumer. So, when it comes to monitoring, so you can get the metrics of this particular stream. How many datas are read, how many datas are put into right into the stream. All these metrics you can understand from here. Then comes the configuration. So once you created a data stream and you wanted to modify the configuration which you put initially during the creation, you can override all those things here. For say, I wanted to increase the write capacity to something else, or read capacity to something else, or I wanted to scale the shots. All these things you can do it here in configurations. Let's understand enhanced fan out. So what is enhanced fan out? By default, so the consumers are provided with 2 MB per second read capacity. So per se, like you have three consumers. So one is a fire hose, one is a managed flink, one is a notification service, which are consuming your data from the stream. So all these consumers can read the data only 2 MB per second. So um, if you want the consumers, each consumer to get a static limit, read capacity limit per se 2 MB per second for each consumer, then you will use something called enhanced fan out, where each consumer consumes the data 2 MB per second. So you can see the data which are coming in into the stream using this data viewer. The data analytics, something which is like Flink, can be integrated directly from here. So this is something like a resource-based policy where you can put your guardrails. Who and all can use this, can access this data stream, and what actions they can do. This is something like a S3 bucket policy. So you can create a policy where you can put guardrails. Yeah, even bridge pipes. So you can create even bridge rules from here. Event-based actions, you can do it here.
Hi everyone, myself Ranjini. I'll be talking about Kinesis Firehouse. So first, let's understand what exactly is Kinesis Firehouse. So Kinesis Firehouse is AWS managed service for moving the data from one place to another. Basically, it is used for streaming the data in near real time. So we are here to talk about how we can tune the Kinesis firewalls so we have optimal performance. So there are four parameters based on these parameters. Tuning Kinesis firehorse can help us to have optimal performance. So by tuning the ingest, so we can set the buffer size of 64 MB and in the interval of 120 seconds, which will give us the high throughput. We can also enable gzip. This will in turn reduce the S3 storage cost. We can also be using the dynamic partitioning. So for error handling, we can configure error. For error handling, we can configure error output prefix so that the failed records land in a separate S3 path for replay. We can also add exponential backoff for throttled records. We can also be using lambda transform rules for returning all the records explicitly and for also giving us the data about the dropped and the processing failed records. We can investigate the timeouts and ensure we have valid 64 encoded responses. We can also monitor the delivery to S3 success and monitor the throttled records. So for monitoring the throttled records, if the value is 0, then it means we have no errors. So let's take a look at it. I, I have a document. I have created a S3 bucket and streamed data to Kinesis Firehose. I am creating Kinesis Firehose and set up whatever we are talking today in the AP South 1. So I have created a S3 bucket. After creating S3 bucket, I have enabled versioning. I have blocked the public access. So let's see if this bucket is available in AWS. So we have a bucket where this bucket is created and versioning is enabled. So we have enabled versioning and we have also blocked the public access. So we have blocked the public access. So let's go back to the document. I will create a IAM role for Firehouse. So I have created a trust policy where I am trusting this service. I'm creating an IAM role and providing the trust policy, whatever I created previously. I am also providing the S3 permission for the Firehouse. After creating the policy, I'm attaching the policy to this role. We will be creating a AWS Firehouse and wait for some time and check if the service is active. So let's check if the service is active. Okay, yes, the service is active. So let's try to see the Kinesis Firehouse in the AWS console. So we have AWS Firehouse in the Kinesis console. So let's try to understand the tuning parameters. So for the tuning parameters, like we already explained, so we have the buffer size of 64 MB. We have also enabled the gzip compression. we are writing the failed records to a different S3 path. So these are the parameters for tuning data firehouse. So we have, and let's understand what these settings mean. So in order to prevent a lot of tiny files in the Firehose, we are waiting for 64 MB to be collected, and then we are pushing this steamed data. We are enabling S3, so this is going to reduce the cost, and this is the best ratio for the text and the JSON data. And this is also readable by the service called as AWS Athena. We are also prefixing the we are prefixing it with the timestamp so that when we can use Athena queries whenever we need to read the data from these partitions. Like I already showed, we are creating an error output prefix where the failed records lands. So let's try to send a test record and see if it is getting delivered. So I'm running this test record. So let's try to see if it is getting. They are 60 base 64 encoded data. So after these records are ingested, I just wanted to look at if they have arrived or not. So they are successfully arrived. So we are able to check the downloaded objects. So we should be able to see this under the date, year, and month. Each file contains a JSON record per. So we have it here. This is a JSON record. So let's try to tune the buffer and check how it is impacted. So we are changing the buffer to a very small size of 1 MB and 10 seconds. So let's observe the rapid delivery and we'll discuss the cost words versus the latency. So I'm updating the destination. So I'm going to send 10 records and I will watch the object count in S3. Impact. So let's see how we can change the buffer size and understand the impact. So I will update the buffer interval. I have already updated the buffer interval. So I will send the test data. So I've sent the batch 1. So let's open another terminal and check for this count. Okay, so batch 3 sent. We have the count as 3. Okay, so we sent 3 batches. So we are able to see the count as well here. So with 1 MB data and 10 seconds of buffer, we see many smaller sizes, potentially 1 per batch. This is expensive in Athena because we have 64 MB is recommended as a starting point. So let's reset the buffer to the optimal size, which was 64 MB. Yes, I've reset the buffer size. Okay. So I have some use cases. Based on the use cases, we can set the buffer size and the interval. So they differ in the lower the buffer size, the higher the cost, and the higher the latency. So let's talk about the troubleshooting part. So for troubleshooting Kinesis Firehose, For example, in case you do not have an S3 permission, what exactly happens? So let's try to remove the permission and check this. So let's check if the policy has been removed. I have deleted the policy. So the policy is removed. So let's send the record so they will fail silently. Okay. IAM policy for S3. Initially, if you see this CloudWatch metric for delivery to S3, it says that the average is 1.0 for all the three batches. However, after I remove the IAM policies, now the data is buffered in the Firehose data, but it is not pushed to S3. That's the reason the average value is not 1.0, it is 0.0. Thank you, everyone. Thanks for joining.
So today we are going to talk about Amazon Managed Service for Apache Flink. So how do business make decisions today? It's all data driven, right? So we collect data sits in a place, and later we have a processing job that runs overnight or a batch processing that is scheduled, and we have the results. So most organizations still have this old book of batch processing, and that is totally irrelevant on the business use cases. But real time, if we see real time decision making, data is generated like even in within milliseconds of large bytes of data are being generated and needs to be processed for real time decision making. So Apache Flink is an open source processing engine mainly designed for this type of streaming applications. So Apache Flink processes data as a continuous stream with sub-second latency. So Apache Flink itself is very well suited for streaming applications where you need every record or event to be processed in a very low latency. So, what is Amazon Managed Service for Apache Flink? So, this is a serverless version of Apache Flink provided by AWS, where we need not manage the servers, clusters, failover configurations. Everything is taken care. Just need to deploy a jar and run the application, and we have a live streaming pipeline ready with us. That is what Amazon Managed Service for Apache Flink in short. So here, this slide shows the overview of Apache Flink. The three core things that I want to talk about Apache Flink. The first is that it helps us build a live streaming pipeline just with few clicks. We can have a Python, a Flink application, a Java, Scala, SQL application uploaded to the managed service, run the application, and we should have the pipeline ready. That is the first core feature that Amazon Managed Service for Apache Flink provides us. The second thing is that it scales automatically. So the billing here is based on the Kinesis processing units and not vCPUs directly. So in turn, one Kinesis processing unit is equal to one vCPU and 4 gigabytes of RAM. So scaling is automatic. We will start with minimum of 2 KPUs, and based on the load, it scales up and down as required. The second thing is it guarantees just once processing. So there is no deduplication logic that we have to specifically enforce. If the application crashes for some reason and we restart it, it processes only the events that was not processed. So Apache Flink has the managed service for Apache Flink has a checkpointing enable every 60 seconds, which ensures that the event is processed just once, which is very, very crucial for financial data applications and machine learning pipelines. Okay. So this is a gist of AWS managed service for Apache Flink. So here I would like to give you a glimpse of real-time use cases. For example, consider a real-time ML inference. So we have our model sitting inside a SageMaker as a SageMaker endpoint, and we have streams of data coming in. Then Flink sits in the middle, and every event is processed by Flink and scored by SageMaker endpoint. So this is one example of how Flink enables real-time ML inference. The same goes with fraud detection. We can see that Kinesis data streams to Flink. Okay, we have a Kinesis data stream, and the data stream is the input source to Flink application where the data streams are being scored and alerts are being configured to SNS or using Lambda. So this is how the Flink can enable processing of live data real time and to have solutions. So one other use case is streaming ETL, where we have to continuously clean, transform, and enrich events before landing them in the data store from where it is being picked. Okay. So anomaly detection, it's a very good use case for anomaly detection, where we have streams of data from different IoT devices to Kinesis to Flink. From there, we can have a CloudWatch or a Lambda doing the notifications for us. Real-time dashboards, where we can aggregate and have data from live KPIs and leaderboards. So the pipeline would be like Kinesis to Flink to OpenSearch or Kibana or QuickSight. So we can have Flink used in clickstream analytics, where it processes user events for real-time personalization and analytics. So these are some of the real-time streaming use cases of Amazon managed service for Apache Flink. So in short, to be very crisp on where we go for Apache Flink is when we need to process streaming data with sub-second latency, and we don't want to worry about the underlying infrastructure scaling or deduplication logic for having the events processed just once. So this is all power packed with Apache Flink. So here I thought that we could put a simple architecture flow. Like when we want to use Apache Flink, the first thing would be the source. So where does the data originate from? What applications? Like the data sources can be any applications, IoT sensors, databases with CDC, clickstreams, and logs. These can be our sources, and we then ingest them to the data streams, like Kinesis data streams or managed service for Apache Kafka, Kinesis Firehose for real-time delivery, and then we have it processed using Apache Flink running connectors. Okay, and then we have the sinks where we want the processed data to go and reside. The sinks can be S3, Redshift, OpenSearch, DynamoDB, or Kinesis Stream for next stage pipelines. So this is to give you an overview of how you can think of a pipeline where you have Flink integrated. With this, we will have a look through a short demo.
So here we are going to see a small demo of AWS managed services for Apache Flink. This demo, I'm just going to uh, input stream and an output stream, which are Kinesis data streams. For the input stream, I will simulate data to the input stream, and my Flink service will process and put them into the example output streams. We are not going to do any major processing, just as this data is going to be transferred from input stream to the output stream using the Apache Flink. So for that, these are the two data streams I have. And in the S3, I have the jar file that is being consumed by my Apache Flink service. So where I have taken this jar file is from the AWS managed service for Apache Flink examples repo from AWS samples repo. In that, under Java, we have a getting started folder. Using that, I built the sample jar file to make the demo very simple. And I have the role created while I have the Apache Flink service. So if you can see here from the Apache managed Flink, I have one application that is running. This is the application, and I can access the dashboard from here. That is the Flink dashboard, and you can see the running jobs. If, and here, can you see from Kinesis source to sync writer, which is the destination? There are no bytes being received at the moment. Let me try to simulate this. Can you see there's one event that is here, and can you see there are a lot of events generated by the data generator script, and going here, refreshing, and can you see here the records received at the writer? So the source sends it to the writer. We can see more details here. Can you just see here record sent, which matches with the records received in the writer? This I am on the source here, and it's like a near real time. So we see a 2:30, and we see a records received at the writer is 2:30. Okay, and you can as well see it from the Kinesis data stream side. Hit on the data stream, and we can click on the data viewer, and just choose your CTF records. See at times. Probably I'll give you. Can you see the records here? And these are just the stock prices that is being simulated here, like AAPL. So we can see that the records are keep on being processed in near real time. So records received at the source side, at the sync side is 628. We go to the source. On the source side, can you see the record sent? And on the sync side, can you see the records? It's the same. Can you see? 721, 721. So from this demo, it is shown that Flink is very much useful in processing data from a streaming application and giving near a real-time output. So this is very much useful in fraud detection or stream. We want our application to store data based on a streaming input. We can rely on Flink. Hope this is useful. Thank you.